Quantum computers are a new kind of computer that are based on the principles of quantum mechanics, a branch of physics that studies the behavior of matter and energy at the smallest scales. Here is a detailed overview of quantum computers. What is a quantum computer? A quantum computer is a type of computer that uses quantum mechanics to perform calculations. Unlike classical computers, which use bits that can be either 0 or 1 to store and process information, quantum computers use quantum bits, qubits, that can be 0, 1, or both at the same time. This allows quantum computers to perform certain types of calculations much faster than classical computers. How does a quantum computer work? Quantum computers use a variety of techniques to manipulate and measure qubits, including superposition. Qubits can exist in multiple states, for example 0 and 1, at the same time, allowing a quantum computer to perform multiple calculations simultaneously. Entanglement. Qubits can become entangled, meaning that the state of one qubit is dependent on the state of another qubit. This allows quantum computers to perform certain types of calculations that are difficult or impossible for classical computers. Quantum gates. Quantum computers use quantum gates to manipulate the states of qubits, similar to how classical computers use logic gates to perform operations on bits. Measurement. When a qubit is measured, it collapses into a specific state, for example 0 or 1, which allows the result of a calculation to be read. What are the advantages of quantum computers? Quantum computers have several potential advantages over classical computers, including speed. Quantum computers can perform certain types of calculations much faster than classical computers, particularly for problems that involve searching or optimization. Security. Quantum computers can potentially be used to break certain types of encryption that are used to protect sensitive data. Simulations. Quantum computers can be used to simulate the behavior of complex systems, such as chemical reactions, which is difficult or impossible for classical computers. What are the challenges of quantum computers? Quantum computers are still in the early stages of development, and there are several challenges that need to be addressed before they can become widely useful, including error correction. Quantum computers are highly susceptible to errors due to factors such as noise and decoherence, which can cause qubits to lose their quantum properties and become unusable. Scalability. Quantum computers currently have a relatively small number of qubits, which limits the size and complexity of problems they can solve. Applications. There are still relatively few applications for quantum computers, and it is not yet clear which types of problems they will be most useful for. Conclusion. Quantum computers are a fascinating new type of computer that are based on the principles of quantum mechanics. While they are still in the early stages of development, they have the potential to revolutionize fields such as cryptography, chemistry, and optimization.